Dear students, today we are going to study cardiac cycle. What is cardiac cycle? It refers to the repeating pattern of contraction and relaxation. So when our heart contracts and relaxes, that is cardiac cycle. Phase of contraction is also known as systole and phase of relaxation is known as diastole. You may have heard the word whenever we are measuring blood pressure of any person or patient, we are using systole and diastole. So the systole is contraction and the diastole is relaxation of heart. Now we have duration. How much time one cardiac cycle takes? How much time one cycle takes? It is usually of zero point 0.8 second. It is usually of zero point 0.8 second. One cardiac cycle gets completed. Now we have stages of cardiac cycle or phases of cardiac cycle. We have usually three phases. Number one phase is joint diastole. Number second is arterial systole. And number third is ventricular systole. So total cardiac cycle is of three phases. Joint diastole, it lasts for zero point 0.4 second. It is the longest phase. Arterial systole, it lasts for zero point 0.3 second. And ventricular systole, it is up. Arterial systole, it is up zero point 0.1 second, and ventricular, it is up zero point 0.3. So total 0.4 plus 1 plus 3 is equal to zero point 0.8 seconds. So longest phase is joint diastole, shortest is arterial, and then we have ventricular systole, that is zero point 0.3. This is arterial systole 0.1 second, ventricular it takes zero point 0.3 second, and joint diastole it takes zero point 0.4 seconds. Now we will see first stage, that is joint diastole. What happens in joint diastole? Number one, we know all the four chambers, all the four chambers of heart, that is auricles and ventricles, are in relaxed stage So in joint diastole, all the four chambers are in joint state. Relaxed state means there is no contraction, they are at resting phase. Second, blood from pulmonary vein and vena cava fills the left and right auricles. We can say right side receives deoxygenated blood from through vena cava, and left side receives oxygenated blood from pulmonary vein. Here we can say this is the heart, these are four chambers, this is auricle, ventricle, this is right auricle, left auricle, right ventricle, left ventricle. Pulmonary artery, see this, pulmonary vein brings blood, that is oxygenated blood, to left auricle, and vena cava or superior vena brings deoxygenated blood to right auricle. Now, what happens third? As the blood moves into as the blood moves into auricles, as the blood moves into auricles, a pressure is created. A pressure is created that causes opening up bicuspid and tricuspid valve. Look here, between the right auricle and right ventricle, there is a valve that is known as tricuspid valve. That is known as tricuspid valve. Between left auricle and left ventricle, there is another that is bicuspid valve. As the blood moves into auricles, the bicuspid and tricuspid valve gets opened. Now the blood starts moving into the ventricles. So from auricles, blood goes into the ventricles. So 70% of blood, 70% of blood goes into ventricles, goes into enjoined diastole. This is also termed as passive filling. Why? Why this is known as passive filling? Because there is no contraction of heart. There is no contraction of. Now, after the completion of joint diastole, another starts. Now, this got completed. Now, it will go into the arterial systole. It will go into the arterial systole. What happens in arterial systole? Listen, look here, dear students. Now, SA node, sinoatrial node, also known as pacemaker, generates action potential. Now it generates SA node contracts, it generates action potential. Due to this action potential, auricles contract. Both auricles contract simultaneously. Due to the contraction of auricles, more blood goes into the more blood goes into the ventricles. More blood goes into the ventricles. Near about, we can say 30% of blood goes into ventricles. So total, we can say 70% of the blood goes by passive filling, and left rest 30% goes due to the contraction of auricles. Remember, auricles are contracting here, but ventricles are under diastole period. Look here, we will see here. There we have SA node. This SA node is located at the top of right auricle. It contracts. It generates impulses. It generates action potential. As it generates action potential, this auricle and this auricle contracts, and the remaining 30% of blood moves into the left and right ventricles. And this phase lasts only for 0.1 second. Now we have third phase, important phase, that is ventricular systole. So we can say now this arterial systole got completed. Now it moves into the another phase, that is ventricular systole. Now ventricular systole, it completed arterial systole, but it goes to ventricular systole. What happens in ventricular systole? As the action potential as the action potential generated by SA node, then reaches to AV node. Remember, SA node is located at the top of right side and AV node is located below the right auricle near to ventricles, and AV node gives this, and SA node generates action potential reaches to AV node. From AV node it reaches to AV bundles. It reaches to AV bundles. From AV bundles it reaches to bundles of his. It reaches to, listen here, look here, dear students. We will see this is SA node. It generates action potential in auricle, and here it is located AV node. So action potential reaches from SA node to AV node. From AV node it reaches to bundle of his. This is bundle of his. From SA node to AV node to AV bundles and then to bundle of his. In this way, whole muscular. This is SA node. This is AV node. Bundle AV bundles. Bundle of his. This is AV bundles. This is bundle of his. So in this way, whole ventricles are contracted. Whole ventricles contracts. Whole ventricles contracts. Now, as the ventricles contract, ventricular pressure is more. As the ventricles contract, this is known as ventricular systole. This is known as ventricular systole. Due to the contraction of ventricles, the bicuspid and tricuspid valve, bicuspid and tricuspid valve are closed. Bicuspid and tricuspid valve are closed. Remember, in joint systole, they were opened as the blood from auricles goes into ventricles. Now, as the blood is in ventricles contract, bicuspid and tricuspid valve are closed to prevent backflow of blood into the auricles. To prevent the backflow of blood, this blood should not go back to the auricles. Ventricle, bicuspid and tricuspid valves are closed. Due to disclosure, there is a sound commonly known as loop, that is marked by first heart sound. Remember, this is very important point. How first heart sound is created? It is created by the closure of bicuspid and tricuspid valve. Bicuspid and tricuspid valve. Now, what happens? As the in this stage, the arteria are under rest. We can say arteria is under diastole. We can say ventricular systole coincides with arteria diastole. Now, due to contraction of ventricles, the ventricular pressure is more. Now, semilunar valves. There are another valves, just like bicuspid and tricuspid. We have another valves, semilunar valves, that guards the pulmonary artery. And aorta. Listen here. We have two. One is pulmonary artery and aorta. They are having two valves. One semilunar valves that are guarding pulmonary artery and aorta, or we can say pulmonary valve and aortic valve. Pulmonary valve. Listen here. Look here. This is the valve here. This valve is up to the pulmonary artery, and second valve, this valve is to the major aorta. The pulmonary artery brings blood to the lungs. And the aorta gives blood to body parts. Now, Due to the contraction of ventricles, the seminal valves are opened and blood starts moving and blood starts moving and blood starts moving to the circulatory pathway to the circulatory pathway. Now the blood starts moving to the circulatory pathway. Look here. Now blood is in ventricles. Blood is in ventricles. Now from ventricles the blood will go. The blood will go. Where it will go? There is a valve. This valve was known as semilunar valve. From right side, this blood will go to the main body parts. This blood will go to main body parts. From left side, this blood will go to the main body parts because this is oxygenated blood. And from right side, this blood will go to lungs. This blood will goes to, and this there is a pulmonary artery. So pulmonary artery carries deoxygenated blood from ventricles towards the lungs, and main aorta carries blood from left ventricle towards the body parts, but there are valves and the blood starts moving to the circulatory pathway Now we can say here another phase, that is ventricular diastole. Now when the ventricles contract, now up to 0.3 seconds they will relax. Now what happens? Ventricles get us empty as blood starts leaving from their respective ventricles. Then ventricles get us empty, ventricular pressure goes down. Ventricular pressure goes down. There is down the pressure of ventricles as blood starts leaving. Due to the downfall of the ventricular pressure, it causes closure of semilunar valves. It causes closure of semilunar valves. During the closure of semilunar valves, there is another sound, that is tube. We can say second heartbeat, second heart sound. So we have two things. First heart sound, that is due to the closure of bicuspid and tricuspid valve, and second heart sound, that is the closure of semilunar valve. When it occurs, when whole blood goes start leaving the ventricles, and there is decrease in the pressure of ventricles, and there is the closure of semilunar valves, that is pulmonary, located on pulmonary artery and aorta, that is marked by dupe or second heart sound. And due to the closure, it prevents the backflow of blood into ventricles. Now again ventricles are in diastole, auricles are also in diastole. Now again status joint diastole, now the cycle will repeat from its initial stage, that is termed as cardiac cycle. Thank you.